Hi YouTube. You ever have a battery that doesn't look like this? This is a 4S battery. It shows 97% and it's got a relatively balanced charge, okay? This battery looked like this one here just a few days ago. These are Flywing batteries that came with the Bell 206. It sits right there, and they came as a multi sort of all-included package. Look, it barely even turns on the system, okay? Because this battery is what I would call dead, okay? Now, there's another way you can try to test it, and that would be to plug it into a voltage alarm. Jeez. But as you can see, it's so dead, it doesn't even show up, okay? Now, if you want to try to restore this to life, first thing I'm going to tell you is do this all in a safe environment and do it while you're paying attention. Don't do it and like go out and do chores in the yard or go to bed or anything like that. It's very dangerous, okay? Or it can be dangerous if you do it wrong. The biggest thing is to be aware of what's happening. These packs are both not puffed. They're not round. They've only been used a few cycles, but they sat for a long time and were allowed to discharge, okay? That can happen and does happen, okay? Lithium polymer packs are generally considered safe and reliable when they're at storage charge levels about 3.8 up to close to 4 volts, okay? If you drop them way below that, they'll fall out of range and the chemistry will become discharged, okay? Once you have one cell that's discharged totally, it screws up the balance chargers because they don't know to sense that there is a cell there. But it can also cause problems with the nominal voltage not showing correct on a charger. So for instance, we'll plug in our good one, we'll show you what it looks like. We'll use a dual charger here. This is an S2200. Now, on this charger, of course, I'm very used to using it. It's got a couple of different connectors. So I can plug in just the balance lead, and it's gonna populate the screen so you can see what the balance level is. Now, in this case, we need to have some sort of an adapter so that we can plug it in. And in our case, we can use either one of these little blue connectors. We actually got these from other batteries. Okay, so we'll just plug that in and then we can charge this. So I press start and I can change my current level because this is not a smart pack. I'll change it down to 4 amps and then I'll go to start, right? And that's the way you would normally see it. And you can see right here, it's populated 98%. It shows those voltages just like we saw on the XBC checker, which is this thing. Should be in everybody's tool bag. Okay, so now what I'm going to do is I'll show you how to fix this battery, because when I plug it in, it's going to populate the screen with some data, except it doesn't because it doesn't even sense it. I have to switch over here and I can see cell 4 is to 1.26 volts DC, okay? AKA, it's dead, right? So how are we going to resolve that? Obviously, you can't just plug this thing in and charge it because it won't sense the correct number of cells. And since it's not a smart battery, you can't start it. I'll demonstrate. It says 4.8 nominal volts. Why does it say 0, 0, 0, and then 1.26 and it says 4.8? That's because when it's below a certain level, it's going to show a 0. So press and hold this, scroll up. We're going to set this to 4 amps like what we would normally do, and we'll just see if we get really lucky. It's probably not going to start. It seems to think it's a 1S. I'm going to change that to 4S and see what happens. 4S, and then I'm going to scroll down to start and see what happens. Abnormal balance port connection, okay? So we can acknowledge that, and it's gonna say nothing, and we scroll down, and you can see it's just basically given up all hope of success. So we can try start again, and nothing will happen. It'll just give you the error, even if it does come out of it, okay? So we'll disconnect the balance lead, and we're gonna disconnect this little adapter we have. I'll press enter to acknowledge so it stops beeping at me. This is going to be the EC3 connector. You could also have an IC3 connector, which would look a little something like this. You know, this would be an IC3 connector. And you could take and have whatever termination point you want, but ultimately, I need to take this, and in my case, I already have a little adapter that has an XT60 that's going to take me to bare leads. Now, I've tied a knot in one so that the leads are different lengths, and it's unlikely that they would accidentally bump. Because once that happens, then kaput, and everybody dies, okay? So what I wanna do is I wanna charge this battery, but I can only charge one cell at a time. So rather than energizing this, I'm gonna plug in one set of cells, okay? This is one cell. Then there's the next 2 wires are 1 cell, the next 2 wires are 1 cell, the next 2 wires are 1 cell. Doesn't matter what order you do it in, but just start with the one that's easy. We'll push that in, and then we'll go ahead and push this in, right? So that's going to basically fit into this. So now you're probably thinking, how did I get those pins? Well, if you're anything like me, you've crashed many planes. And every time you crash a plane, you don't always get battery leads like this, but sometimes you do. This is the female end of it. Sometimes you'll damage the battery, sometimes you'll damage the plane itself. And so I've built so many connectors that I have the male and female connectors in kits, and I just yank them out of the housing. And then I solder them onto my little short lead, and I just put them on my XT60 as prescribed by here, minus and plus. That's the way I did it. Plus and minus, okay? Keep your polarities right. Now I can plug this in and watch what happens on channel 2. It goes to 1.2 volts, okay? So now I can press the start button. Obviously, we're not gonna charge it as a 4S, so we have to highlight that and scroll it down to 1S. We're gonna definitely not charge it that fast because we got small leads. We wanna keep it at sub 1 amp, but I'll just show you at about half an amp. And let's see what happens. If you're in Lipos, sometimes it works, sometimes it doesn't. Now it's gonna say no balance lead detected. That's because it's not plugged in through the balance lead. I'm gonna continue without balancing. Now watch what happens. It starts. It kicks on the current. And then you press down and look at this. 2.1 volts, 2.2 volts, 2 point whatever, 2.4 volts, okay? So now we don't need to let this charge for long. The other thing is, zoom out, camera crew, let's show the people. You can closely monitor your connections to make sure that you're safe. Generally not a good idea to do this with a battery that's puffed, damaged, physically poked, anything like that. If it looks like a round cylinder, that's bad. It needs to be square, it needs to have straight sides, and that's gonna let you know that you have the most resiliency. Now I've found that these chargers like to see something like about 2.5 to 3 volts before they disallow the cell from being considered a cell, okay? So now we're at 2.8 volts, so that's good enough to move on. So 2.9 now. So I can just press play and hit stop, okay? Now, all I have to do is quite literally disconnect my positive, move my negative down to the next one, okay? Then plug in my next positive, and you see I'm just working my way down the Hextronics balance lead, okay? So now that's gonna charge this cell. That's 1 cell. Now watch this, we have 1.3 volts there. So we're gonna press and hold start. We don't even need to change the settings, and we'll press start again. Then we're gonna acknowledge that we're gonna continue without balancing, and it's gonna start. Then I'm gonna press down, and we can populate the screen with the voltage. We're at 1.5, that's not enough for us to let it be. So now we're at 1.9, now we're at 2, now we're at 2.1, now we're at 2.2. Now, if in doubt, guys, look at this. Very carefully touch the cables to feel if they're warm. You're only 0.5 amps at about 4 volts. So it's very low wattage. So there's not much power going there. Now, am I gonna pull that out and lick it? No, I'm not gonna do that. And I don't wanna do it with screwed up connectors. So we're at 2.7, so good enough. I can press play, stop, and I'm gonna lift up my balance lead, make sure we're at 0 amps, we are. Disconnect the positive, then disconnect my negative, move down 1 pin, and then I can plug this in. Now we're gonna charge this one. Look, we're at 1.2 volts already. Okay, so press and hold start. Scroll down, we're still at LiPo 1S. Acknowledge that we're gonna balance without the balancing lead. Now it's gonna bring up your value. It's gonna populate here. Scroll down, you can see we're charging. We're at 1. Okay, now 2.0, and so on and so forth. And this is the way you can do this with up to as many cells as you want. Okay, now some of you are probably thinking, yeah, that's great, Brian, but I'm trying to solve a problem with one of my smart packs. Okay, how do you do that? Well, we'll talk about that after we get this one done. Let's see if you can make it through this. Okay, so we're at 2.4 volts, probably good enough. You'll notice it comes up pretty quick toward the end. So I'm gonna press play. I'm even gonna stop it right now. Then I'm gonna come up here. I'm gonna disconnect this. Guys, full disclosure, this is all being done live and in charge right now. No pre-planning except for having the stuff laid out. No battery, it's going between no battery detected and so on and so forth. Then I'm gonna hit start. I'm gonna acknowledge without a lead. Now, there is another trick. If it doesn't start for you, this one did start, okay? So I can go down here and it looks like it's bringing the voltage up, okay? If in doubt, you can change the battery chemistry from lipo to lead, okay? So what I'll do is I'll stop this one and I'll show you how to do that. This, again, this is only under very close, probably adult supervision if you're a kid, or if you're an adult and you don't understand electronics, maybe just don't do this. Just throw away the battery and get a new one. Lipo, we're gonna change to lead acid. Lead, and we're gonna scroll down, keep your current low, make sure it says 1S, and then I'm gonna start. Now watch this, it's gonna change the way that it tabulates the power that's in there, okay? And it's just bringing it up the same way. The difference is it's gonna say high voltage warning earlier, which is not all that bad because a lead cell would be less than a lithium polymer, okay? So I'm gonna go ahead and stop it because we're at 2.6, and now it says 3, okay? Now I'm gonna come down here. I'll unplug this, and then I'll unplug my little extension cord thingy, and now I can put away my leads. You guys can see how this is made. This is just the Hextronics balance lead plug. So that's like the pin that would be on the charger end. And, you know, if you crash a plane and you've got one of those voltage alarms like this, that's another place you can get those pins, which is really nice. If you've got one broke off, you can just break one off and you can use those to solder on. So it's super easy to do. If you know how to solder, it should be no problem. So I'll just lay this aside for now. Now I should be able to change my lead acid battery back to lipo, okay? Once we're on lipo, I'll plug in my discharge lead. It's probably going to recognize it, but if not, oh, look at that. All 4 are showing up. So now I should be able to press start and I can start charging slow, or I can go up here and put that up to closer to like 1C rate, because now we're gonna force the current through the discharge lead into the battery, through the discharge lead into the battery, and then we're gonna simultaneously balance. So the way you can review that is now from here, it's kicking up the current. I'm gonna bring it down one step. You can see it's gonna draw this up slowly. Now over here on on channel 1, you can press down and you can see that all these are balanced nicely. This battery had the exact same condition as this before we made our delicious breakfast for lunch as a family. So I usually try to charge them slow when I'm bringing them out and back from death. But if you have a sticky note that reads something like this on a battery that reminds you that it's not working, here's the catch. You can do that on close supervision. Now, my suggestion is always the same on these. Keep that note, stick it on the side of the battery, and then the next time that you go to use that aircraft, okay, say it's in a day or two, no big deal. Your note will remind you to check for that performance issue. If you have that performance issue again, my rule of thumb is usually if it's been a long time, maybe it's a fluke. But if it's been a short time, it's probably a bad pack. Replace it, okay? I usually give them one try. We have a lot of batteries. There's more risk with a lot than there is with a little, okay? If you have a few batteries and this happens, it will be easy for you to segregate one battery at a time. And yes, I do have smart batteries that have done this to me before. Here's one. Props only. This is one that I had that gave me 3200 6S. It doesn't look to be in bad shape. Just have one cell that sags on that particular cell, okay? That happens to be a Gen 1. And so because it's a Gen 1, I could quite easily fix this one as well. But my suggestion to you would be, if in doubt, replace the pack. If it's rough, replace the plaque. If there's physical damage to any of those cells, in this case, our example was 4 cells, you wanna make sure you specifically look at the sides so you can see if there's any pierced points. If there are, you would have already known because it would have started smoking, okay? But generally speaking, after an accident or crash, that's where you're gonna get caught. Let's show the people the voltages. Look, we're back up into nominal ranges now. Now it's actually showing charge. Now the cool thing is you can also see how many milliamp hours have been forced into that pack. Now this is a 4,000, right? No, yeah, 3,000 milliamp hour pack. I put 2,264 milliamp hours into this pack, same size, 3,000. And generally when you discharge a battery, like let's just use this one for example, so we throw out another totally unrelated. This might only discharge about 1800, maybe 1900 milliamp hours in a flight time, and then it's going to be spent, okay? If you're charging the full capacity of a pack every time you fly, you're running it to 0 and beyond percent, okay? So you're probably hitting low voltage protection, and you guys see the way I fly. I fly until the engine's pulsing or the motor's pulsing in our case, or goes to low voltage cutoff or any of that stuff. You've seen it before. Sometimes my thrust reverse doesn't work because I've used up all my power. So my suggestion is, if you decide to take this on, 1, be close, 2, be prepared, and 3, if there's damage, if there's persistence, just throw it away, get rid of it, and follow the proper throwaway procedures. You don't want to be the guy that put it in your garbage can and then burn the garbage truck, which does happen, so don't be that guy. There are proper procedures for getting rid of these batteries. I like to take them out back and shoot them, like with a 22, which is dangerous, but you don't have to do that. I used to drive a nail through them. That's even more dangerous. Okay. My suggestion is don't listen to what I say, find the legal way to do it and do it that way. Okay. There's probably battery recycling programs where you live, look it up, find out what's safe and do that thing. But the key is if it's totally discharged, there's still lithium in there. So the lithium is technically a hazardous material. So just be careful. So hopefully that helps get you up to speed. And by the way, that's using a modern charger. That's not using an older style charger. It's not using some off the wall charger. If you have something that doesn't give you as much sophistication, you might consider getting an S2200. This is a really good robust charger, 200 watts per charger. This is an S155. We could have used this, done all the same features, but it would have been just a little bit slower. And to be honest, we aren't even tapping the full potential of this for this type of application. The S1200 is just gonna be one channel, does all the same features, still gives you all the connectors. Another tool that's really handy to have is if you have one of these breakout boards. I've always found this to be really handy if you're gonna be doing a lot of charging and trying to do things like this, because then you can build adapters that are a little easier to work out. So you could actually build connectors that would plug only one cell at a time and you could have them ready to go, okay? So there's all sorts of creative ways you can do it. But again, I come back to point number 3. If it's frequent, it's bad. If it's more than once or twice in the life of a battery, you got a bunk battery. Sometimes they come shipped and you'll get a battery, like say it's a smart battery. Sometimes you get bad errors like this too. But say you get a smart battery and it comes out of the package and you got one cell that doesn't populate on the screen, or it populates as really low, like 1.77 volts, and the others are 3.8, 3.8, 3.9, or something like that, okay, on a 4S pack. There's not as many remedies on a smart pack that's a Gen 2, because you have a circuit that looks like this, minus your balance lead, okay? So then this little balancing circuit that's underneath this edge of your battery, this is one that's in a little bit rougher shape. You can see it's kind of rounding out. That's not necessarily good. This would be mounted right under there, okay? So it would actually be kind of like straddling here, let's say, something like that. Then you have your balance lead. Well, in this case, this is Gen 2. This would be a Gen 1. You're like, how do you do that? The only way that I've found to get a battery to start that's a smart battery is you have to force in a little bit of battery power. And this is where you really want to work at your own risk, okay? Protective equipment might be necessary. The factory is going to tell you, just throw it away, get a new one. Obviously, they want to sell you a new one, but they obviously don't want you to burn your house down, okay? So you can do it where it's safe. Say it's a 4S like this, and say you have a 4S like this. Well, how do you jumpstart this battery? First of all, plug it into the charger, see if you can get it to start. If it doesn't start or it doesn't register, then what I will do is I will take a similar size and I will make the connection from polarity to polarity. So plus to plus, minus to minus. How do you do that? Well, there's a bunch of different ways you can do it, but I always found that the easiest way to do these types of things is to get like parallel adapters and things like this. And then what you can do is you can, well, parallel, that's a series adapter, my apologies. I will find a connector and I will make an adapter that will plug into the battery, okay? So it'll go like this, and then I'll have another battery adapter that goes to this, okay? And I will literally hold the leads so that I'm touching with my fingers the leads, and then I can plug it in and I'll give it like a count to 2 or 3. They'll get warm quickly. You'll discharge so fast from here to here. It's like the fastest, most dangerous discharge you can do. That's usually enough to get the voltage up high enough to then quickly put it into the charger and then get your voltage into the battery, okay? Now again, I'm not gonna demonstrate that exactly because I don't actually have one that I know of that's bad right now, so I'm not gonna dig for one. I'm sure I could find one if I looked hard enough. But when and if you do that, the catch is that if you put it together with a way bigger battery or a battery that's at 4.2 volts fully charged and you're trying to bring something up that's at 0 volts or at 1.7 volts, then there's a larger differential, which means that there's gonna be a quicker draw of energy from this side to this side. So you have to be careful because you can burn out the circuitry that actually does the balancing, okay? Now that being said, I don't think you're gonna have a problem with it if you do it for a second or two, but you don't wanna be doing that with like 8S packs and big, huge batteries, because then you just go back to doing one cell at a time. And if you can't, then you just, better luck next battery, because they're expensive. I don't wanna lose them either. But it's better to lose a battery than it is to lose a hand or an eye or a face or get burned or have a fire in your house or burn your house down, burn your kitchen down, something like that. So a couple different tips would be hard surface, sight, hear exactly what's going on, know what's going on, know what you're doing, be careful, don't be lazy. Get one pin at a time, don't try to save time. Do it the safe way. Keep them separate. Don't ever have your positive and negative touch, okay? If you can't handle those things, then it's just a new battery for you every time you have one that fails on you. And admittedly, I don't have it happen all that often. But if you have dumb packs, meaning not smart packs that like to draw down like that, it's almost always symptomatic of a bad battery. So don't be afraid to occasionally replace the battery if you have a bad battery, especially when they start getting plump. This would be an example of plump, okay? That's plump. Why is it plump? Because I overdrive these things like crazy, okay? All right, hopefully we answered some questions for you. If you have comments, leave them down below. Remember, do this at your own risk. I know a lot about this stuff, but everybody has different situations. Sometimes when cells go bad, it's because there's an internal connection that breaks. And if you try to do this, you'll immediately have problems and you may even break your charger. So just remember, there's always a risk to everything you do. Don't blame me if you take the risk and you make a mistake, but just be careful. If you really want to make this super ultra safe, what you can do is you can take these leads and you can run them through a small fuse. Put a fuse holder, like an inline fuse holder that twists open, and you can put a fuse in there. That would help protect you. You can do one on each side, positive and negative. But just keep in mind, you have to keep within the confines now of that fuse. And I would recommend a slow blow 1 amp fuse. They're expensive for being a fuse. And if you don't want to do a slow blow, I'd recommend going no bigger than 2 or 3 amps anyway, because those are small leads and you don't want to put a bunch of current through them because you'll melt them easy. Also, only use the wire that's got the silicone coating and not the kind that have that hard plastic coating, because that's a lot easier to melt. So, all right, more battery tips and tricks here on Brian Phillips RC. We want to help you guys get out of the chair and into the air, and part of the way we can do that is by teaching you how to do some of the more complicated things in the hobby. Not that this is especially complicated, it just happens to be a common problem. So thanks for watching. We hope we answered your questions. If you want to support us, check us out on brianphillipsrc.com or bprc.me. And if you want to support us in other ways, you can buy things like the chargers that we just showed, the batteries that we just demonstrated. We'll put links in the video description below so you can support us. Also, special thanks to Buddy. We just worked with them here the other day on this iCharger. This is a DX8, and you can do all the stuff we showed you on the DX8 that we did on this, but it's actually a more expensive charger. So we wanted to show it on something that's a little bit more what we're used to, okay? Also, if you want to support us in ways that are not buying these particular chargers, transmitters, radios, things like that, we have Patreon, PayPal, YouTube Super Thanks, and YouTube members. So all those things are always wide open for the taking. But we know that a lot of people struggle with this, and batteries are expensive. So if you got a one-off weirdo cell that draws down on one flight and you want to try to fix it, give it a shot, be safe, you'll probably save it. And then if you've got one that keeps doing it 2, 3, 4 times, you probably just have a bad battery. All right, that's all we got for you. Stay tuned, so much more right around the corner on Brian Phillips RC.